So we start the discussion with few illustrations. Read this question. In this question, the ratio of radii of two wires, right, of the same materials are in 2:1, right? R1, suppose this is the R1 and this is R2. So R1 upon R2 is equal to what? Say 2:1, right? And they are hanging, suppose, and find if they are stretched by the same force. If the force is same, so they will all elongate it. Are you getting? Material is same. The material is same mean their Young modulus is same. So what is the definition of the Young modulus? Say stress upon strain, delta L upon L. Is it clear? What they are asking? The ratio of stress. Okay. So they are asking the ratio of stress. So what is the stress? Stress is equal to force upon area. Force upon pi r square. Is it clear or not? So if the force is same, so the stress 1 upon stress 2, the ratio I am asking, right? Finding pi r1 square upon f upon pi r2 square. All right. So this is equal to r2 upon r1 whole square. What is r2? It is 1 by 2. R2 upon R1 is 1 by 2, right? So this is equal to 1 by 4. So the ratio of the stresses, right, in the wire 1 and in wire 2 is equal to 1:4, right? Copy this. So read this question. In this question, right, you have to find the longitudinal stress and the tangential, that is the shear stress, right, on the fixed block, right? Suppose this is the cuboid, right, and this is the three faces are given as the 5 meter and this is the 2 meter, right, and this height is given as the 1 meter, and the force is applied the 100 Newton, right, on this surface, and this angle is assumed to be 30 degree. So this is the F perpendicular, which is equal to 100 sine 30, right, and this is the F parallel, you can say, right, is equal to 100 cos 30, right. So what is the area of this surface? Please tell. The area is nothing but length 5 meter into width 5 into 2. It is equal to 10 meter square. Is it clear or not? You tell. This is the area. So it is fixed over here. All right. So to find the longitudinal stress, what is the longitudinal stress? Perpendicular force upon area. So perpendicular force is this and tangential force is this. So perpendicular force is 100 sine 30 is equal to 50 Newton. So it is equal to 50 Newton. And what about the area upon which this normal force or perpendicular force is applied? It is equal to 5 into 2 is equal to 10 meter per second square. So longitudinal stress is 5 Newton per meter square. All right. And what about the shear stress or tangential stress? Tangential stress is nothing but the parallel force applied divided by area. So this is the parallel force is equal to 100 cos 30. It is root 3 by 2. It is 50 root 3 Newton. So this is 50 root 3 divided by what is the area? So the area is 10 is equal to 5 root 3 Newton per meter square. So this is the longitudinal stress and this is the shear stress or tangential stress, right? Copy this. So read this question. In this question, a bar of cross section area A is given like this, right? And equal and opposite force F are acting over here, right? And consider the plane. Now you have to consider this is the plane, right? One plane, right? This is the one cross section area you have to consider, and making an angle theta with the plane, right? Bar making theta with a plane at right angle to the bar length. So this is the bar length and this angle is what is to be theta. Is it clear or not? So now at this plane, this is the plane, right? At this plane we have to find the tangential stress and the shear stress. All right. If the mass of this length, of the bar length is L, mass M, and F and F are applied. So you tell me, it is in net force is what? So 0. So it is in equilibrium or not? Yes, equilibrium. Equilibrium. What does it mean? It means net force is 0 if you consider this portion only, right? This portion like this. This is the force F. If the force F is acting and this portion, right, is in equilibrium, the area you may assume, listen one more thing, that this area of cross section is what? This area of cross section is A. Are you getting or not? So if it is in equilibrium, what should be the force applied? You tell me on this body, on this remaining part, right, on this section, the leftmost section, what should be the force? If it is F, it must be F. Are you getting? This force is applied by this right hand part on the left hand part. Is it clear or not? So the force acting on this portion is F in this way. Is it clear or not? You tell. If this angle is theta, right, this is the area. So this area will be supposed to be the A dash. First, I will write the relation between A dash and A. So if you write the cos theta is what? Base upon hypotenuse. You may write in this way. So the A dash, that is the area of this, is A upon cos theta. This is the first relation. Now, if you consider this is the surface, right, this is the A dash. If this is the surface, right, you tell, if this is theta, this angle is theta, right? If this is theta, this is theta, this is 90 minus theta, and this is theta, this is theta, this is 90 minus theta, and this is theta. All right, theta, this is 90 minus theta, and therefore this is theta. If this force is applied F, and this is the plane, so what is the force perpendicular to the plane? This is the force perpendicular to the plane, and the component of cos theta, F cos theta, will be equal to what? F cos theta will be equal to F perpendicular, and it is the component, the parallel force is acting over here, which is equal to F sin theta. All right. So if you consider this is the plane, this is the tangential force acting. The tangential force acting is F sin theta, and the normal force acting over here is F cos theta. You understand this thing or not? Right. So in the first part, they are asking what? The longitude, tensile stress. Tensile stress. Tensile stress is nothing but perpendicular force upon area. Here the area will be equal to A dash. Right. So what is the perpendicular force, you tell? It is equal to F cos theta. And what is the A dash, you tell? In terms of this cross section area A. Right. This is the A. So this is equal to A upon cos theta. So the tensile stress is F upon A cos square theta in this case. All right. Second thing is shear stress, right, or tangential stress. Shear or tangential stress. Tangential stress is nothing but parallel force upon area. So what is the parallel force? Say F sin theta divided by area is the A dash. It is nothing but A upon cos theta, which may be written as F upon A sin theta into cos theta. Is it clear or not? If you multiply by 2 in the numerator and denominator, so it become equal to what? Say F upon 2A, and it become sin 2 theta. Right. So this is the tensile stress. This is the tangential stress in this case. Right. Copy this. So read this question. In this question, right, the area of cross section of wire, right, of length, suppose length is 1.1 meter, all right, and the area of this cross section of this wire is what? 1 millimeter square, all right, and it is loaded with 1 kg. If this wire is loaded with 1 kg, so then what will happen? its length will be increased or not, right? So delta L is increased, and the Young modulus of this copper wire is 1.1 into 10 is why 11 Newton per meter square. Is it clear or not? And it is loaded by 1 kg. Is it clear? So the increase in the length we have to find. So if this wire is very small, its mass is supposed to be negligible. So if you consider this is the load of 1 kg, so this is the 1g acting downward. So the tension in this string, right, or the restoring force, right, is T is equal to what? It is equal to 1g. So tension in this wire is equal to 1g, which is equal to force in this wire, right? So Young modulus is given, the stress, this is the stress means this is the perpendicular force acting over here, right? So the perpendicular force acting over here is 1g upon A delta L upon L. So it may be written as F perpendicular upon A delta L upon L is equal to Y. So delta L is nothing but perpendicular force upon L upon Y. You have to remember, right? So if you put the value delta L is equal to, what is the perpendicular force? Say 1g is equal to 1 into 10, right? It is 10 Newton. Area given as 1 millimeter square, mean 10 to the power minus 6 meter square it is. Fine. The length L is given as 1.1 meter and the Young modulus is 1.1 into 10 to the power 11. Right. So it will, if you simplify this, 10 upon, in the denominator minus 6 and 11, 10 to the power 5 it is. So when it moves 10 to the power minus 4, it is 0.1 into 10 to the power minus 3 meter, which is equal to 0.1 millimeter is the elongation. All right, this is the solution, right? Listen, one more thing, you have to remember a little idea about the value of the Young modulus of the copper and other material one by one. So for the copper you will remember 1.1 10 to the power 11 is the Young modulus of the copper, right? It will be very helpful if you remember the practical data, right, like copper, steel, right? Not only in this chapter, as for example the density of the mercury, did you remember or forget? 13.6 into 10 to the power 3. Although it will be given in the question, but you, some practical data you must remember to, for better understanding. For example, density of the air is 1.29 kg per meter cube. Whenever you get this type of the data, you should actually you should remember, or you have to think about this, how much its magnitude is, what is its order, right? Like that. Copy this. So in this question, the steel and copper wire of the same length. Suppose this is the steel wire, right? And this is the copper wire, right? This is the copper wire. Young modulus of steel. Young modulus of steel is 2 into 10 to the power 11 Newton per meter square. And the Young modulus of the copper is what? 1.2 into 10 to the power 11. Right, it is little different from the previous question, but you can assume to according to the question. So steel has the more Young modulus, it is more elastic than copper. The material which has the more Young modulus or the coefficient of elasticity is more, it is more elastic, right? I will explain this. And now it is, right, elongated by the same force, the ratio of the increase in length. So Young modulus is what? Stress upon strain, right? May be written as F upon A into delta L into L. So delta L is nothing but F upon L upon Y into A, right? Same length, the ratio, the one after another, same by the same weight. The weight mean they are applying the same force, you can say. So the ratio, the force is same, the length is same, the length of the two wires same. The Young modulus is different, although it is not given the idea about the area, right? So I will assume it is the same also, but this, it is mistake in the question and it should be given the area also. So delta L from here, the area is same, F is same, L is same. So change in length is inversely proportional to the Young modulus. So delta L upon of steel divided by delta L in copper is equal to Young modulus of copper, Young modulus of steel. Right. So what is the Young modulus of copper? It is 1.2 into 10 ki power 11. What is the steel? It is 2 into 10 ki power 11. So everything will cancel out. 1.2 divided by 2. It is 12 upon 20 is equal to 3 upon 5. Right. So the B option is the correct option. This is 3 upon 5. B option is the correct option. Copy this. Okay, so read this question. In this question, two wires of copper having the length in the ratio. Okay, this is the 4, right? This is the one wire. The length is L1 and L2. The length ratio is 4:1. And the radii, right? Suppose this is the radii are also given as 1:4, right? Its radius is what? R1. Its radius is R2. So R1 upon R2 is given as 1:4, stretched by the same force. So the longitudinal, the force is same. Longitudinal strain you have to find. So the Young modulus is what? Say stress upon strain. So the longitudinal strain delta L upon L is nothing but F upon A into Y. So this is the formula for the longitudinal strain. So what we have to find? We have to find delta L upon L in the 1, delta L upon L into 2. Divide is equal to F upon A1 into Y1, F upon A2 into Y2. Right. And the copper wire and the length, the ratio of longitudinal strain is this. So it is equal to A2 Y2 upon A1 Y1, right? So what we have to do, the ratio of longitudinal strain is delta L upon L is equal to F upon, so they have not given the Y, right? Okay, no problem. Listen, one thing, if this is A2 is what? Pi R2 square Y2 upon pi R1 square Y1. So in the longitudinal strain does not depend upon the L, so it will not be used. So it is equal to R2 upon R1 and Y2 upon Y1, but the values are not given. So the two wires of the copper having, okay, so both wires are of copper, all right. So therefore their Y and Y will be the same, so it will not come. Both wires, two wires of copper, right? So it is equal to what? Say R2 upon R1. So R2 upon R1 is what? From here 42 upon 1 square, 16 upon 1. So this is the ratio of the longitudinal strain, and the B option is the correct option, right? Copy this. So read this question. In this case, in which case there is a maximum extension or elongation in the wire. If the same force is applied on is the wire, you have to find, right? Suppose this is the wire and the force F is applied. Suppose there is the area of cross section is A, right? So the elongation in the wire, right, when the force F is applied is equal to delta L. So the Young modulus is what? Stress upon strain, delta L upon L, right? And elongation delta L upon L is equal to F upon Y into A. So therefore the L is equal to what? Like this. So the elongation, the same on each wire will be the same. So elongation depends upon what? The same force is same, the length is different, and Young modulus is same. So elongation depends upon the length of the wire, right? The length of the wire assumed to be capital L, suppose, right? L, and the area. Area is nothing but pi r square, right? and the radius is nothing but d by 2. So the delta L is proportional to L upon pi d square by 4. So the elongation, if the wire is same, and the force is same, the Young modulus and y force are same, so it is proportional to L upon A, L upon pi r square d square. Elongation is proportional to L upon d square. L is the length, right, and d is the diameter. So in the case A B C D, right, so delta L upon A is to delta L in B is to delta L is to C is to delta L into D, right. I'm writing just LA upon DA square, LB DB square, right, LC DC square, LD DD square. So what is the length A given? 500. The diameter is 0.04. I am not writing in the unit, right, since this is the ratio and the unit will cancel out. So LB is what? 200 is to 0.02 is to 300, length in C, and it is 0.03 is to 400. Wait for 1 minute. It is square. It is 0.01 square. All right. So it is 500 upon 25 into 10 की power minus 4 is to 200 upon 4 into 10 की power minus 4, 300 upon 9 into 10 की power minus 4, 400 upon 1 into 10 की power minus 4. So minus 4 minus 4 minus 4 will cancel out. Also these two 0 will cancel out. So it will remain 5 upon 25, 2 upon 4 is to 3 upon 9 is to 4. So it is 1 upon 5 is to 1 by 2 is to 1 by 3 is to 4. Haji, yes. Which elongation is maximum util? In the wire D, the elongation is maximum. Therefore, delta L of D is greater, right? Then delta B is greater than delta C is greater than delta L into A. So elongation of the D is maximum, then in B, then in C, then in A, right? Copy this. So read this question. In this case, the length of elastic string is a meter, right? It is a meter when longitudinal tension 4 Newton. So length of elastic string is a meter. Suppose this is the a meter. When there is no elongation, suppose the length is L0, when there is no force is applied. So the force 4 Newton, the a meter. Then yes, when the longitudinal tension is 5 Newton, yes, what is the string length? Say b meter. So they are asking the length in the length of the meter supposed to be c. You have to find, right, when the longitudinal force is applied to be 9 Newton. This is the question. All right. So we can assume that the initial length is L0, Young modulus is y, right? This is the thing. So Young modulus is what? The delta L. Young modulus is f upon a into delta L upon L. So delta L is nothing but f upon a into y into L naught. L naught is the initial length. All right. So in this case, when the force is 4 Newton, the length is how much? A. So what is the elongation? Say it is a minus L naught. So therefore, in this case, a minus L naught is equal to force. What is the force? 4 Newton into L naught, all right, divided by area into Young modulus. In this case, what is the length? Extra length. The total length is B, so length is L naught. without the original length is L0. So what is the elongation? Say B minus L0. So B minus L0, when the force is applied 5 Newton upon L0 into A into Y. Is it clear or not, Utal? Fine. Now the elongation is what? Say C upon L0. C minus L0 is equal to force is applied is equal to what? Say 9 Newton upon L0 upon A into Y. Is it clear or not, Utal? Fine. So how to find the C in terms of AB? All right. So what to do? Listen one thing. I will give you 1 minute to think about this and solve. Copy this. So let's see how to solve this. The value of C is to be represented in terms of A and B. Is it clear or not, Utal? So what can we have? If this is the equation number 1 and equation number 2, if you subtract 1 minus 2, right? So what will you get? A minus L0 minus B minus L0 is equal to, this is 4 minus 5, 4 L0 upon YA minus 5 L0 upon AY minus L0 upon AY, right? It will cancel out. It is A minus B is equal to what? Minus L0 upon A into Y, right? So B minus A is equal to L0 upon A into Y. This is the one thing, right? And what to do? To find the value of C, we have to put the value of L0 upon AY and the value of L0 also, right? So this is the value of L0 A upon Y. Only the value of L0 we have to find. So how to do that? Listen one thing. L0 upon AY, maybe from 1, it is divided by 4. A minus L0 divided by 4. This 4 come in the denominator and it is equal to L0 upon AY. If you divide it by 5, B minus L0 upon 5 is equal to L0 upon, right, L0 upon A into Y. Is it clear or not? So now both L0 upon AY, L0 upon AY is same. So we can make equal. A minus L0 upon 4 is equal to B minus L0 upon 5. Simplify. If you simplify 5, A minus L0, 4, B minus L0. So it is 5A minus 5L0, 4B minus 4L0. So it is 5A minus 4B is equal to 5L0 minus 4L0. So it is equal to L0. So value of L0 is 5A minus 4B. Is it clear or not, Utal? So now we found the value of L0. Also we found the value of L0 by A. Now from equation third, right? C is equal to L0 plus, C is equal to L0 plus A, L0 upon AY, right? The value of L0 is 5A minus 4B plus 9. It is 9. It is 9, not A. 9 into, what is the L0 upon AY? B minus A. It is 5A minus 4B plus 9B minus 9A. So it is equal to what? 5B minus 4A. All right. So the answer is 5B minus 4A. So this is the length of the wire C, when the 9 Newton force is applied. So it becomes 5B minus 4A. So which option is the correct option? The B option is the correct option, right? Copy this. So read this question. In this question, you have to find out the shift in the point BCD when the load 10 kg is applied, right? Suppose this is the initial length, right? This is the point B, this is the point C, and this is the point D. All right. What is given, although there is a mistake in the figure, printed mistake. This is 0.1 meter. It is given as 0.2 meter, the length of this portion is, and the 0.15 meter. Is it clear or not? And the young modulus of this, right? Suppose this is the point A. So this young modulus AB is given as 2.5 into 10 to the power 5. Oh, sorry, 10 to the power 10. 10 to the power 10 Newton per meter square. For this portion, for the BC, it is given as 4 into 10 to the power 10, right, Newton per meter square. For this portion, CD, the young modulus is given as 1 into 10 to the power 10 Newton per meter square. Now, when the some load is applied, right, so there will be shift. The point B will be shifted to this point, the point C will be shifted to this point, the point D shifted to this point when the 10 kg load is applied. Is it clear or not? So they are asking the shift in the point B, they are asking the shift in the point C, they are asking the shift in the point D. Is it clear or not? For first, this is the shift in the point B we have to find. Although this is the 10G, so the tension in each wire will be equal to what? Right? Tension in this wire will be equal to 10G, 10G, 10G. So this is under stress, right? What is acha? The area of cross section of each wire is also given in the question, and it is minus 7 meter square if you see. All right. So every wire is in the stress, equal stress is applied. What is the stress, you tell? The stress in each wire is force upon area, that is mg upon area. What is m? Say 10. What is g? It is 10. What is the area? 10 to the power minus 7. So what is the stress? Every on 10 to the power 9 Newton per meter square. Is it clear or not, you tell? So for the wire AB, for AB, right, so delta L may be written as young modulus is equal to stress upon strain, right? So stress upon strain, what is the strain? Say it is equal to delta L upon L, right? So delta L, that is this elongation, is nothing but L upon, it means capital L upon what? Y into stress. The stress is common. So what is its length? You tell it is 0.1. What is its young modulus? Say 2.5 into 10 to the power 10. What is the stress we have found? 10 to the power 9. Is it clear or not? So when you will simplify this, 1 upon 25, point will cancel out, and it is 1 upon 10. All right. So this is in meter. So if you want to write in millimeter, so 1 upon 250 into 10 to the power 3 millimeter. So it is equal to 4 millimeter, right? So delta L is 4 millimeter. So the point B is shifted to, right? It is shifted by, what is that? Say it is it is 4 millimeter. You understand or not? Please tell. In the same way, the shift in the point C also to be found. So how to find the this length, this elongation delta L, you have to find first. Suppose this is the elongation delta L1. So delta L1 we have found 4 millimeter. Can you find the elongation in this portion BC? For BC, look at the figure. For BC, right, delta L2 we have to find, right? First copy this, then I will explain, otherwise you will confused, right? Copy this. Now find the elongation in this part BC, because it is the under stress of 10 to the power 9 Newton meter. So elongation may be written as, in the part BC, is equal to length upon young modulus into stress. So what is the length of this part? For the BC part, it is what? 0.2 meter. What is the young modulus of this BC part? Say 4 into 10 to the power 10. And what is the stress? Stress is same because it is connected in series like that. So you will simplify this. It is 0.2 upon 40, right? So it may be written as 1 upon, right, 2 upon 400. It is 200 meter. So in millimeter, how much it is? 10 ki power 3 millimeter, right? So how much it is? 5 millimeter. Is it clear or not? So the elongation in the part BC is 5 millimeter, right? But they are asking the shift in the point, right? So this is the elongation, but the B is already shifted by 4 millimeter, and this is more elongation by 5 millimeter. So it is shifted, right? This is the elongation. So this point C is shifted, right? Therefore, C is shifted by, tell me, 4 due to the shift in the B plus due to the elongation in C in this part. So it shifted by 4 millimeter plus 5 millimeter is equal to 9 millimeter. Is it clear or not? You tell. So is it 9 millimeter? Yes. Okay. Now in the same way for part CD, what is the elongation in this part? It is the under stress, the length upon y into stress. So length is what of this portion? 0.15. The Young modulus is 1 into 10 ki power 10. The stress is 10 ki power 9. So it is how much? Please tell. It is 0.15 upon 10. It is 0.015 meter. So therefore, it is in millimeter, it is 15 millimeter. Are you getting or not? So 4 millimeter is the elongation in this part, 5 millimeter elongation in this part, and 15 millimeter elongation in this part. So by what distance it will shift? Therefore, the point D is shifted by distance. This is 5, this is 4 plus this is 5, right, plus 15. So just 24 millimeter, right? So this point is shifted by 24 millimeter. Is it correct or not? Copy this.